Hello and welcome to Toot 1049, Unleashing the Power of Salt with SUSE Manager. In this session, we'll cover three main topics. First, what is salt and why should I care? How does SUSE Manager use salt and why does SUSE Manager use salt? And then finally, how can I use salt for my own nefarious purposes? My name is Niel Bornstein. I'm a senior sales engineer with SUSE, living and working in the southeastern United States. My contact information is listed here. So if you have any questions about this session, feel free to contact me and I'll do my best to answer you. So to begin with, what is salt and why should I care? So first of all, what is salt? Salt is built on Python. It uses a simple and human readable YAML to configure it and create the salt states. Along with event-driven automation that helps you deploy and configure complex IT systems. Salt includes a remote execution engine, so you can execute tasks remotely. It includes a configuration management system, which allows you to configure your systems. It allows you to apply defined states so that you can always make sure that the systems you are working with end up in the right state. It enables high-speed communication between the master and the minions, and we'll talk more about those two types of nodes in a minute. It does provisioning and orchestration. It's easy to extend, and best of all, it's written in Python. The SALT project is an open source project independent of SUSE, but we have adopted it in several of our products. How would you run Salt? Well, there's a couple different ways to run it. You can just go get the source from GitHub. Currently, the version is 3004. You see the URL there on GitHub where you could go and get the code and compile it and run it yourself. Of course, that's unsupported. So if you want a supported version, you can actually install Salt from the SUSE Linux Enterprise repositories. Or if you're running OpenSUSE, you can get it from the OpenSUSE repos. Again, the OpenSUSE version is 3004, same as the upstream version. The enterprise version is at 3002.2. So that's another way to run it supported. Or you can just install SUSE Manager. SUSE Manager includes Salt, and if you want to use SUSE Manager in your environment, you get Salt for free. There's multiple ways to run Salt in either the supported or unsupported configurations. There's a master list configuration. There's even an agent list configuration, so you could have no master and no agents. Or you can run in the traditional master minion configuration, master being the main server and the minion being the agents that run on the managed devices. You can also use Salt to manage dumb devices that can't run Python themselves using what's called a Salt proxy. And you can run with multiple masters. This is something we're actually working with in SUSE Manager as well. So let's talk a little bit about the architecture of SALT and some of the terminology that you'll see as we go along. The first thing is the master and minion architecture. You can see here there's a SALT master that listens on ports 4505 and 4506. There are minions on the right side, and there are multiple types of minions, and you can have many minions connected to a single master. They communicate using 0MQ. 0MQ is an open source universal messaging library. SALT uses 0MQ as the default transport protocol. So again, we have two channels, two ports open on the SALT master, and two different ways of communicating: the pub sub socket on 4505 and the request response socket on 4506. 0MQ also supports TCP and rate transport, but no need to get into too much detail on those. Just know that 0MQ is the messaging transport for SALT. Some of the other important components to know about with SALT are there's a master. The SALT master issues commands to any minions that are attached to it. The master acts as a central control bus for those minions. The minions connect back to the master. So if you were to install this as a standalone SALT master, you could just use zipper install, again, as we mentioned before, from the repositories. Zipper install salt master, gets you a salt master. Then you can configure it using files in the Etsy salt master directory, the Etsy salt master file, and then the Etsy salt master.d directory contains additional configuration files. Now the master controls the minions. The minions are the salt clients. They connect back to the salt master and are controlled by the salt master. Again, they connect over 0MQ in a typical configuration. Typically, there's a daemon running on the minion nodes called salt minion. In SUSE Manager, these are salt clients. We have different kinds of clients for SUSE Manager. Traditionally, we had the old style of minion or old style of clients, which were not salt minions. We're just going to call them salt clients, salt minions. We can change the terminology as we go. We're talking about the same thing, no matter what words we use. And again, a standalone installation, you would just run zipper install salt minion. And like the master, there are configuration files. There's the main configuration file in Etsy salt minion. There are additional configuration files in the minion.d directory. And then there's one special file, the minion ID, which you can set to set the ID of the minion. This can also be set in other places, but that's a file that SUSE Manager uses, so it's good to know about it. When a salt minion connects to the salt master, it exchanges fingerprints between the two nodes. These are used to verify the identity of the server and the client. So this can prevent you from accepting minions that are out of your scope of control. You can see these in SUSE Manager. If you navigate to the salt keys page, you can see all the connected nodes, all the connected minions, and accept or reject those keys. And we'll talk more about that later. Now, this is a very important part about salt. States are configuration templates. They allow you to describe what each of your systems should look like, including any applications and services that are installed and running. So states are applied to the target client or minion by the master. This automates the process of bringing a large number of systems into a known state and then maintaining them in that known state. There is some good documentation in the SaltStack website, SaltStack being the company that maintains Salt. Their documentation is top-notch, and I recommend looking there if you want to learn more about states. The next thing to know about is the high state. The high state is really the accumulation of all the states that need to be applied to minions. So when you're making changes to systems, you apply the high state, and that will go through and do everything that it needs to do. This could be installing packages, this could be removing packages, changing configuration files, enabling and disabling formulas, all sorts of things like that. You can do this from the command line using the salt command. You can see here a typical salt command, the salt command itself, the target where you want to apply it, and this is a regular expression, so in this case, apply it to all minions, and then the state.highState is a command to apply. Now, that state.highState is a command that's applied. The state part of it is the name of a module, and then the high state is the command to use from that module. There are many different modules included with Salt. There are state modules and execution modules. So, for example, a state module might change the state of a system to make it look how you want it to look. And then an execution module would run a particular command. So modules can be used to alter the behavior of a state file. It can be used to encapsulate logic using Jinja, or it could be used to retrieve information from the minions. And we can talk more about what kind of information is passed back and forth in a minute. There's a complete list of available Salt modules in the SaltStack documentation, or you can write your own Salt modules. Everything in Salt is written in Python and YAML, so you can do anything you want to extend the functionality of Salt using Python. Now, we talked about passing information back and forth between the minion and the master. Grains are one way that's done. Grains provide information about typically the hardware of a client. This can include the operating system, type, IP addresses, network interfaces, memory, things like that. Again, the documentation on grains is good, so you can learn more about grains. The grains are information about the client. That's the important aspect of grains. Another type of information is pillars. Now, pillars are information that is created and stored on the master. So this can contain information about a single minion or a group of minions. They allow you to send information to a client based on what you know about those clients and other information that you have stored on the master. So that's good for sensitive data, configuration, variables, and any kind of arbitrary data you want to send to the minion. Again, there's a link there to the documentation from SALT. Now, formulas are a collection of SALT states that contain parameter fields. So think of it as a way of putting variables or parameters into a SALT state. These formulas are used, for example, within SUSE Manager to assist configuring SALT clients. Some of them have very extensive configuration options, and for those, we actually have forms within SUSE Manager that help organize them and help you complete the data when you're applying that information to your minions. Now here we have some documentation on formulas from the SUSE Manager documentation. So I would point out that that's a different set of documentation than we've been looking at before. So that gets us to, how does SUSE Manager use SALT and why? Well, so to get into that, we have to talk about a little bit of history. SUSE Manager was originally based on Red Hat's Spacewalk project, which brought with it a lot of great functionality. However, when we released SUSE Manager 3, we wanted to make some changes to the task automation framework. We felt that it was not extensible enough, not fast enough, and really just it didn't scale well. So when we released SUSE Manager 3 in 2016, we took that Spacewalk open source project and we added SALT to it as the task automation framework. Then as time went on, we decided to actually fork the Spacewalk project, and we created the Uyuni project. So that's the new upstream for SUSE Manager. It has been since 2018, so about 4 years now. You can see the URL for the Uyuni project listed here, as well as the source on GitHub. It's still open source, as everything that SUSE does is. And you can take a look at the project. In fact, you can go and install Uyuni from upstream if you wish and play with it before you decide to make a purchase of SUSE Manager. So what were the challenges that we wanted to solve by adding SALT? The first thing is scale. We were looking at environments that had thousands of servers to be managed, and the old framework really didn't scale that well. We wanted to be able to parallelize tasks because, again, the old framework did not perform tasks in parallel. It was synchronous. So you would set up a task to be run, and it would run on one node at a time and wait for that node to return and then go to the next node. So we wanted to make sure that we could do those tasks in parallel in a short time window. And then finally, we wanted to be able to express tasks as declarative states so that we were not telling the systems what to do. Rather, we were telling them what we wanted to achieve and allowing them to do the right thing to make that happen. So why did we choose SALT? Well, the key strengths we looked at were, first, SALT has the master and minion architecture or masterless architecture. It's very flexible. You can deploy it in many different ways. Similarly, it can be run agent full or agentless, either running the minion on the managed nodes or using SALT SSH for an agentless architecture. It allowed permanent encrypted and authenticated connections using 0MQ, so it was not needing to stand up a new connection every time some task was sent to one of the managed nodes. SALT has an open API, so it's easy to integrate third-party functionality, whether that's cloud functionality or third-party software functionality. So very easy to extend the functionality of SALT. It does that asynchronous data collection and command execution that I was talking about, so that multiple tasks can be done to multiple clients at the same time. It's very lightweight and efficient, again, written in Python, so no huge Java clients, nothing that has to be installed, nothing heavyweight on each minion, or again, even nothing on each minion in the case of an agentless configuration. It allows both imperative and declarative state design. So again, the declarative state meaning I want to tell you how I want you to look when you're done doing this thing, and imperative meaning here are the tasks I want you to execute. It allows both. It has a very strong developer and user community, which is important to us as SUSE. We want to make sure we are involved in the communities and involving the community in what we do. And then finally, it integrates well with existing configuration management frameworks. So if you're using some other framework like Puppet, Chef, Ansible, what have you, we can sit side by side with those very easily. So that was a very important factor in the choice of SALT. So let's look at some of the things that SALT enables in SUSE Manager. The first thing is remote execution. That's important. That's what a lot of SUSE Manager does. It allows you to actually run tasks on the minions rather than the server. There's no point in having a single point of failure, a single node that can get overloaded when everything's running on the server and only sending out minimal tasks to the clients. So there's so much more work that happens on the server. With SALT, we do the work on the minions rather than on the server, and the server just sort of orchestrates those things. We get the ability to enable new features through SALT states and formulas. For example, our monitoring and SUSE Manager for retail products. These all use SALT, and it's just a matter of writing a few SALT states, creating a few forms in SUSE Manager, and it's very easy to implement these things and add new functionality to SUSE Manager. And then communication via proxy is included in the framework. So for a long time, SUSE Manager has had a proxy, which was a separate piece of software. Using SALT, we just use SALT proxy. It's very simple to install, and it's enabled us to do a lot of great things without having to reinvent proxies. And the most important thing is that SUSE Manager is itself a SALT master. So the SALT master is part of the SUSE Manager infrastructure, and it's set up for you by default. You really don't have to do anything to take advantage of SALT on the SUSE Manager server. It uses the serve SALT directory for any content you want to create. So you can take advantage of that SALT master being there. It's also it's what SUSE Manager uses internally for all of its configuration management. And the best thing about SALT is that the minions are supported on all of these different Linux distributions that you see here. SALT minions also run on other operating systems, including Windows and Unixes and lots of other things. We obviously are only supporting Linux through SUSE Manager, but there's a whole bunch of different Linuxes that you can work with. So what do we do with SALT? Well, SUSE Manager takes advantage of lots of SALT functionality to do higher level tasks, such as system inventories. We use SALT to query systems, and remember using grains, for example. We're gathering information about those SUSE Manager clients. We're able to do patch management with SALT using declarative states. We declare what versions of packages we want installed, and the minions go out and make that happen. We can do service pack migration with SALT. It's just using the built-in functionality of SALT, all directed by SUSE Manager. We do image building and deployment using SALT boot, for example, to configure new systems or to upgrade existing systems. One very powerful module that we contributed to the SALT ecosystem is Ansible Gate. A lot of our customers are using, as I mentioned before, other configuration management frameworks in their environments. You might have Ansible already in your environment. So there was a SUSE Hack Week project to bring the ability to control Ansible from SUSE Manager. The 2.9 version of Ansible is provided in the SUSE Manager Client Tools channel, and there's a new system type in SUSE Manager of Ansible control node. Now, we don't provide Ansible packages for non-SUSE operating systems. However, you are free to use Ansible to control those non-SUSE operating systems. There's third-party packages for all of those operating systems already. What you can do is you can schedule Ansible playbook execution As you would with any other action in SUSE Manager. You can onboard those Ansible control nodes, you discover them in SUSE Manager, and then schedule those playbooks to run. Another thing we've done and contributed to the SALT community is Yomi, which is yet one more installer. There's a SALT formula, states and modules, and an operating system image that includes the SALT minion. So this is a way of installing new systems when you want to install unattended nodes. It's an alternative to AutoYes that's integrated completely into SUSE Manager. Uses PXE, uses a remotely delivered kernel and initRD or an ISO image. So I talked a little bit about using an agentless alternative for SALT. So SALT SSH allows you to execute SALT commands and states without installing the SALT minion. So there may be some reason why you can't install SALT packages, or you might not want to have the SALT minion constantly running as a service. In those cases, SUSE Manager connects over SSH and installs the needed components temporarily, just while it's executing. So you need to have Python on that remote system unless you use the push via SSH contact method. The Python version is needed to be it needs to be the same version that we use when we do an actual SALT-based installation. But one important thing to remember is if you do select to onboard a client as agentless, that is a permanent selection unless you reactivate that client. I talked a little about formulas earlier. Here are some formulas that are provided by default with SUSE Manager. You can see there's a few here. You can create your own formulas as well, and there are other formulas that you can install from other RPMs. So you can see there's things like configuring bind, configuring DHCPD, image syncs, monitoring, the branch networking for SUSE Manager for retail. We have things that are there for HANA and SAP specific functionality like SAP HANA formula, the SAP cluster formula, the Yomi formula, which I just talked about, and of course the custom formulas that you can create and install. Now, another SUSE Hack Week project was formulas with forms. So forms are a graphical representation of the formula's parameter data. So when any of those things I'm going to go back to the previous slide, any of these formulas that are provided with the SUSE Manager, there's obviously some data that has to be put in here to make these work. You use the forms to fill out the data and then apply them to your minions. And those forms are defined with YAML. It gives you an opportunity to define what type of entry field you want to have, whether it's a free text or a number or a drop-down box or a checkbox. And then it tells you how to create that form on the screen and then send that data to the formula that will be used to apply to the minion. SALT bundling is a way to manage a system with two different SALT masters. And this is coming in the next version of SUSE Manager. This allows the SALT minion to be installed with its own Python executable SALT minion and runtime environment. So this would allow you to, say, use SALT Enterprise for some functionality and SUSE Manager for other functionality on the same system. Now, it's important that you don't try and manage the same things twice from two different masters. This is a recipe for disaster. When you have two sources of truth, chances are both of them are going to be wrong. But this is great functionality for those cases where you do need to have two separate sets of management from two different masters. This is something that's new with the latest version of SUSE Manager. We now support pay-as-you-go clients on the public cloud using SUSE Manager. So how this works is you basically, normally with SUSE Manager, you sync content from the SUSE Customer Center, mirror it down to SUSE Manager. Now we're actually able to sync that content from RMT servers in the public cloud. So that makes it a lot easier for PAYGO instances in the cloud because you don't have to go through what was previously a very cumbersome process of requesting a zero-cost subscription just to have the SCC entitlement there. This functionality works in all three major public clouds, AWS, GCP, and Azure, and it uses a SALT state. to query the channel entitlements by masquerading as the pay-as-you-go client, and then populating those channel entitlements based on the client's entitlements. Again, completely implemented using SALT. And so we've talked about some of these things that we've contributed to the community. Here's a list of several of the other things that we have contributed up to SALT. The zipper and snapper modules. This is functionality that is not exclusive to SUSE, but we invented the technology, so we have contributed control of those things up to the SALT community. The libvirt virtualization module, the Ansible gate that I already talked about. We've made contributions to SALT SSH. We've added functionality around transactional updates that we invented for SLE Micro. We contributed the Docker and Kiwi modules, an asynchronous batch client, as well as contributions to the SALT core and general bug fixing. So now let's get to the meat of it. How can I use SALT for my own nefarious purposes? And for this, I'm going to show you some demos. So we'll switch over to the demo. I'm going to begin by showing a few commands you can run from your SALT master. In this case, it's the SUSE Manager console, but it's the SALT master, so no matter how you're running SALT, this should work. The first one is I'm going to run a ping command, and you see I have to do this as root, so I'm using sudo, and I'm going to run the SALT command. I'm going to target systems with my initials on them using a regular expression. And then from the test module, I'm going to run the ping command. So we should see 3 systems coming back, responding to the ping with true. You see the minion ID and then the response to that command. So very simple command to run. I can do other more complex things. I can run arbitrary commands, for example. So I'll run this one. Here I'm again targeting those same systems, NMB, with the star for the global expression. And then I'm going to use from the command module, the run command. And the command I'm going to run is just to print the date. And you'll see that they will come back. They're actually running asynchronously. So these are running in parallel. However, they're coming back at slightly different times because the millisecond portion of the date will show that, whatever time it happens to be. Now, we've already seen that I can target systems by name. I can do more fine-grained than that if I want. So, for example, I know I have some systems that are called test. So I'll target just those test systems. And again, I'll do a test.ping. And we should see only one system come back from this ping. There it is, my one test system. So anything you can do in a regular expression, you can do there. Now, SUSE Manager stores SALT configuration files in a couple of places. So by default, there's the etc SALT master. So let's go ahead and take a look at etc SALT master. That is a file. And then there's also the master.d directory that contains other files. So SUSE Manager itself uses the master.d SUSEManager.conf file. Don't ever touch that file. That is created by SUSE Manager and managed by SUSE Manager. If you need to create your own configuration files for specific things, you can create another file in this directory for your own purposes. For example, this autoaccept.conf is an example of that. Files are searched in the order they appear, and the first matching file that contains a configuration you're interested in will be used. Now, the next thing I will show you is how to accept minions. We talked about exchanging keys earlier. I can look at, I have to do this as root also. I can say salt key, and I can just say list all the keys that are there. Now, one thing I'll say about this is in SUSE Manager, this is showing me all keys no matter how many organizations you have set up in SUSE Manager. So I'm going to see quite a few keys here. This is one of the areas where it's important to use SUSE Manager when appropriate, using the console rather than using the SALT command line directly. I can do things like accepting, and again, I have to do this as root. I can accept any outstanding keys using the salt key -a. Right now, there are none that are have not been accepted. But if there were, it would give me a list and allow me to say yes or no. Now, you can also set SUSE Manager to automatically accept all connections. To do that, there is a file that I created previously in the master.d, and it is the autoaccept.conf file. And you can see it just has one line, is autoaccept true. You would only want to do this in a highly controlled environment where you know there's not going to be any systems trying to connect to your SUSE Manager Salt Master without your permission. Now, I talked about pillars earlier. We can do things with pillars. We can look at where the pillars are stored, and we can target systems based on pillars. So one thing we can do is I can get all of the pillars for a given system. So if I say salt, I'm going to, again, use my test system. I can use the pillar.items command and see all of the pillars that exist for that system. And you can see there's quite a few of them out here. If I want to say get a specific pillar, I can say pillar.get and then the name of the pillar. So for example, I can see what groups this system belongs to. Now here, this is just giving me a group ID, not highly useful here unless I happen to know what that group is. But it's out there. It's all stored in pillars. You won't typically want to target systems based on those pillars. You can use the UI, but if you really want to, you can go out and get all of the systems that are in a given time zone, for example. That's stored in a pillar. So I can say salt minus I time zone name est, and then ping those systems. So all the systems that I have configured that are in Eastern Standard Time are being targeted, just like I targeted by name previously. Now I'm targeting by a pillar value. And this actually may not return because I probably have some systems out there that are not up and running. This is, again, we're looking at how you can use salt. Not necessarily should you use salt, but it's there. I'm going to cancel that one. Now, grains are similar. I can go and look at grains for my system. And again, targeting NNB test. And just like with pillars, I can get grains. So for this system, here are all the grains that are available. And then I can, again, target a system based on grains. So like I did with the pillars, targeting everything with that particular time zone, I can target using the minus capital G, every system that is OS family SUSE, and again, test.ping. And again, this will not return because I have systems. Well, I'm wrong. These are returning because the grains are stored on the SUSE Manager server itself, not on the system. So I know all about these systems, even though they're not necessarily up and running. Now let's look at some state files. So SUSE Manager server saves state files in several locations. User share SUSE Manager. Let's go ahead and take a look. User share SUSE Manager salt. So there's some state files. They're in user share salt formulas states. There's some there. There's some in user share SUSE Manager formulas states. And then there's some in serve SUSE Manager salt. So all these places are places where states can be stored. Don't touch any of those. For your own purposes, you can just use serve salt. If you need to create any states of your own, put them in there, serve salt. Now, you can create your own states. You can do them from the command line by creating files and putting them in that directory, that serve salt directory, or you can do it through the SUSE Manager UI. So let's take a look at the SUSE Manager UI now. So in SUSE Manager, we call these configuration channels. So let's take a look at configuration channels, and we can see there's a bunch of them out here in this particular test system. I have some that I can pick and choose and play with them. Let me take a look at disable SE Linux. So here's a state, and what it's going to do is disable SE Linux. That's pretty simple. I can view the state file itself right here. Here's the contents of it. And you can see what it's going to do is it's going to copy a file from the SUSE Manager server, set its owner and group to root, and set its permissions. And the source of it is going to come from here on the SALT server, the SALT master, in the directory manager org2, disable SE Linux. It's going to copy this file. Basically, this config file is going to be copied down to this location on the minion. So all I have to do is apply this state file to a system, and it will do what it needs to do. So let me look at how that is done. If I pick a system, I will pick one of my systems again. And since we're using the test, I'll go ahead and use that one. And I can click on states, and I can assign a state to that system. So I go to configuration channels, and I look for it, disable SE Linux, assign it, and save changes. Confirm that, and now that is assigned to that system. So we can go back here to my high state, and we can see here's all the states that are assigned to this system and will be part of the high state. So if I want to apply that, I can click on apply high state, and all of these things will be applied to that system. I'll do that right now, applying the high state. And like everything with SUSE Manager, I can do it during a maintenance window, or I can do it immediately, depending on how my system is configured. So that is a bit of the power of SUSE Manager and SALT. I hope you've enjoyed this session. If you have any questions, my contact information is available. I will also be responding to comments and questions on the SUSECON console during the first showing of this session, and I'm happy to answer any additional questions you might have. Thank you, and enjoy the rest of the show.